We are live, apparently. Hooray! And hoping that there's going to be a lot less issues compared to last time. If anyone was here on my last live stream for signing books, the Wi-Fi dropped and the live stream link was wrong and all sorts. I'm hoping you can all hear me. If you can't hear me, let me know in the chat, because I've never used this microphone with... Yeah, people are saying yes. This is all good. So we're here because I'm signing 400 copies of my book, the US version of my book, Space at the Speed of Light. This is going to be available for any of you in the US and Canada this time, because last time you Canadians couldn't get it. So this time I made sure with the publishers who are sorting out this whole thing with the signatures to make sure that you can get it to Canada. I'm not in control of the shipping charges, unfortunately, but that's all I can do, I'm afraid. They're a little bit expensive, not more than I would play, but they're not too bad as far as I know. So the link to buy one will be available in the description after the stream has ended, and I'll post it on my social media and stuff as well. If you're not here from the US and Canada, don't forget that in the rest of the world, it's the UK version. This is the same book. I know a lot of people get confused by that. The US just wanted to change the title. This is what it is in the rest of the world. If you just want to purchase it, it's called Space 10 Things You Should Know. And if we've got any Germans around as well, I now have the German version of my book. That's the back. It's called Das kleine Buch vom großen Nahl, and I probably absolutely butchered that, but there you go. I like it because it's shiny. I'm signing these little sticker things that will get sent back to the US and then stuck in all the books and then sent out by the publishers. So let's get cracking. I'm going to be taking questions as I do it because I got 400 of these things to go. I have a little bit of rum to help me through it as well. Cheers, everybody. It is 8 o'clock here, so I think it's fine. And like last time, I've got Sam over reading the questions on the live chat that are coming through, and he's going to be fielding them to me. He's sat over there in a chair with a beer of his own. So let's get cracking. Sam, what's the first question? Well, I've stumped him already.
I'm not going to take it.
Hang on. Well, there was a question that came through on my post before that I saw. That was someone who was saying, did you see the news about the bolide that was over Japan? And I did see that news, which is really cool. For those of you who didn't see, a bolide is essentially a ridiculously bright meteor. I don't know what the exact sort of threshold in brightness it has to cross before it becomes a bolide, but in my head, it's the kind of meteor that, like, even someone who isn't like switched on to the night sky and isn't like, oh, I know where constellations are, like if that happened, they'd be like, what on earth is that? Because they'd see it streak across the sky. And so there was one of those over Japan last night, which was pretty cool. It's essentially just a large lump of rock burning up in the Earth's atmosphere, and it gets really bright as it goes, which is really quite cool. All right, do we have another question from the live chat?
Yeah, so first question up from Pete.
Pete.
What is the process that powers stars?
Pete asks, what's the process that powers stars? That is nuclear fusion, which is when a star takes hydrogen atoms and fuses them together to become helium atoms. So in a hydrogen atom, you have one proton in the very center in the nucleus, and in a helium atom, you have 2 protons and 2 neucleuses. Sorry, 2 neutrons in the nucleus. There's that rum I'm going to blame. And so essentially, to make helium out of hydrogen, you need 4 hydrogen atoms to get 1 of helium. And so you need an incredibly dense and very hot environment for that to even happen. So it's actually only in the inner, like 10% of the sun that actually happens, but it gives us enough energy so that we can all survive here on Earth, which is pretty cool. And it's something that a lot of people here on Earth are trying to replicate. Obviously, it's very difficult to recreate that environment, but also sort of keep everything contained as well, sort of in a reaction. So it's very difficult. Next question.
Question from Barry Smith.
Barry Smith. Hello, Barry Smith.
Do you use the mnemonic "Oh, be a fine girl, kiss me" to remember the stellar classification system, the Morgan-Keenan system?
Yes, I do use that mnemonic. It's, oh, be a fine girl, or oh, be a fine girl or guy, kiss me. It's really, really common. Like, I've never heard it called the Morgan-Keenan system. In my head, it's the Harvard classification system that was come up with by Annie Jump Cannon when she was sort of a computer at Harvard. But yeah, it's the mnemonic that everybody learns it, not even at grad school. Like, we learned it, didn't we, Sam, in like physics lectures at undergrad. And yeah, it's to remember all the different types of stars, O and B stars being the most massive and the hottest, and then K and M stars being the sort of tiny little red dwarf type things. Our sun is a G star. So yeah, it's a pretty good way to remember it. I have loads of different mnemonics like that. I mean, I know people have them for planets in the solar system as well. Like the most common one in the UK is my very easy method just speeds up naming planets when Pluto is still a planet. But when I was a kid, I learned many volcanoes erupt mulberry jam sandwiches under nuclear pressure, which I've been told is possibly one of the most British things that anybody's ever heard. So next question.
Question from Nathan.
Hi, Nathan.
To do with expansion of the universe.
Oh.
Is the universe undergoing constant acceleration? And you might mean expansion there, or has it been under variable expansion throughout its lifetime?
Does he mean like constant? Do you mean constant speed or constant acceleration there? Because it's accelerating. Yeah, so it's accelerating, expanding. Therefore, it is accelerating. I don't know what. Like, do we know the exact acceleration? Is it always increasing its acceleration? It's increasing the speed at which it's expanding, but I don't know if it's increasing its acceleration. I'd have to look that up, Nathan. What was the second half of the question?
So he was asking, is it constant or is it changing throughout its lifetime?
Yeah, I don't know. I'd have to look that up. As far as I know, it's accelerating expansion, but I don't know if the acceleration value itself is also changing. So I know that like dv by dt is changing, but is dA by dt changing? I don't know. I have to look it up. Not looked at that for a while. Too busy thinking about galaxies and black holes every day. That's a question for a cosmologist proper. Another question?
Okay, question from George or Jorge, I'm not sure.
Hi, Jorge, George, whoever you are.
Have you ever considered writing another book?
Oh, funny you should say that. I have definitely considered it. And that consideration might have turned into something more concrete recently. That's all I'll say. All right, I think I'm through maybe like 50 maybe. There's quite a few there that I've signed, just so you can see. All right, next question.
So a question from Michelle.
Hi, Michelle.
On the subject of planets. So why are the orbits of planets elliptical and not circular?
It's literally a probability thing. So a circle is a very specific type of ellipse, right? It's the point at which, you know, what we call the semi-major axis and the major axis are the same, right? In an ellipse, you have one short side and one long side. So a circle is just a very special point of that where they're exactly the same. And so probabilistically, if you're going to set something in an orbit around something that's going to be stable, it's probably much more likely to form an ellipse than it is a perfect circle. So because ellipses are stable, like there's nothing sort of overly special either way. Like a circle is just a, you know, very unlikely possibility when you're just going to form something that forms a loop around another object. So just probability's sake. It's nothing like there's this major thing about the universe that makes it they're elliptical. It's just coincidence. Can you guys hear Sam when he reads out the questions or not? If not, I'll try and repeat them. Let him know in the chat if you can hear him.
Okay, so next question from Dhruv Patel.
Hello, Dhruv.
Looking back at your PhD, what was the best part of it? And is there anything you think you could have done better?
It was the best part of it finishing it. No, I think the best part of it was going observing, definitely. Like just field trips are always the best parts, right, of any sort of science thing, I always think. So we've got to go to La Palma in the Canary Islands as part of my PhD to take some data with the Isaac Newton telescope. I got to go to Hawaii and use the Caltech submillimeter observatory, which is the sort of silver golf ball on top of Mauna Kea. That was incredible as well. Like they were both just incredible trips. Like, you know, having the night sky there. I went diving in both places as well because I'm a big scuba diver, so it was great. And so I absolutely loved it. Just, you know, being left in charge of like $1 million equipment, you know, for the night while you're slightly sleep deprived is an odd sensation, but it's really fun. In terms of what have I done better? There's so much I look back upon in my research, right, that I think, oh, I would have liked to have done this differently then, or there's a different way I could have done this. But that all comes with, just learning on the job, really, I guess is the way to say it, like with experience and, with hindsight and everything like that. Some of the work that I did right when I started my thesis back in like 2014, I know that I could have done things differently. But it's still good work, and I'm building on it now. And it's, in work that I'm doing now, I'm doing it differently, if I'm using a similar method or whatever. And so I kind of guess like by staying in research, you get to improve on your thesis research all the time anyway, which is pretty cool. Good question. Thank you. I don't get to talk about my PhD thesis very often. So it's actually behind me on the shelf up there. I would get up and get it, but I'm not going to.
All right. Next question from Rohin.
Hi, Rohin.
Why are galaxies typically spiral shaped? And why are they not just randomly shaped?
Oh, okay. So I guess, first of all, so the question was, I don't know if you heard it, but it was why is galaxies are spiral shaped and not just like random shapes? So all galaxies tend to start life as disc shaped, not necessarily having spiral structure in that flat disc. And that's essentially because as gas clumps together in the early universe, it will start spinning just because you've got so many gravitational interactions going on there that eventually stuff will start moving and falling into gravitational potentials and it'll start spinning. And we all know, as we see pizza dough thrown above chefs' heads, if you set something spinning, you can turn something that's a round ball into a flat disc. So that's why a lot of galaxies start life as flat discs. And then they can also develop spiral structure as well. We're not entirely sure how spiral structure forms. There's a couple of different mechanisms that we can sort of make it form in that way in simulations. But there's no sort of observations that have given us a concrete answer for which mechanism is at work in terms of like density waves or anything like that. And then as opposed to why they're not random shapes, you do get more random shapes of galaxies as galaxies evolve. So as they interact with other galaxies, as they merge together with other galaxies, you ruin that spiral structure and you can make something that's sort of blob shaped. But then also as they interact and you get these huge big like tidal tails being torn off with stars in them just being ripped apart, you can form all manner of shapes, right? You have the penguin galaxy, you have like the mice galaxies, you have the pinwheel galaxy. There's so many different sort of random shapes that end up being made just by this sort of interaction of gravity in a system. My pen is slowly running out. I might have to get another one. I think there's another one in the box behind me. So let's hear the next question while I get another pen out. Ooh.
So there's lots of questions about stars coming in.
Okay.
So a question from Jonathan. In what part of the star's life cycle do the heavier elements get created?
That would be right at the end. So that was a question from Jonathan on when do the heaviest elements in a star's lifetime get created? And it's literally right as the star runs out of fuel. So in terms of nuclear fusion, the star will always just be doing hydrogen into helium because it's the easiest thing it can do. But as I said before, that only the inner 10% of a star is actually where nuclear fusion takes place. So as soon as that inner 10% of hydrogen is all turned into helium, you've then got an inert core that it can't do anything with. So nuclear fusion stops for a fraction of a second, and then gravity starts to win, compresses the star down a little bit, but then all of a sudden it's dense enough and hot enough for more hydrogen burning to start in a little shell outside of that core. And you sort of have this like this sort of like pulsations going where it gets hot enough and then it doesn't, and then it contracts again. And then eventually it gets hot enough to kickstart like helium burning into things like carbon, and then carbon burning into all the heavier elements as well. So that only happens in the very sort of late stages before a star either sheds all its layers or perhaps goes supernova or something like that. It's only in supernova, though, do you create the heaviest of heavy elements, the things like iron and stuff like that. That's the only time that you actually get the conditions that you need to actually have nuclear fusion into things like iron. And it's only stuff like, white dwarf supernova, even when you have a white dwarf and it gets more massive as it gets, sort of drags mass off something else, like another star, for example, that you create sort of elements heavier than iron as well. So it's really fun, actually. You can find, if you search for an astronomer's periodic table online, you'll find this thing that shows you in what astrophysics process are all the elements formed. And there's sort of like really detailed ones, but then there's ones that's literally just kind of like past iron. It's like supernova poop. And that's how I think of all of the elements past iron. Like I'm currently wearing supernova poop. This is a little necklace, which is one of my favorites. It's Ursa Major, you know, the bear constellation. I don't know if you guys can actually see that, but yeah, that's Ursa Major, or the Big Dipper, or the Plough, whatever you want to call it. Okay, I think I'm about 100 in, because I'm about halfway through the first stack of stuff that I have to go. See? Yeah.
All right. Got a question from Nero, and we were actually watching this on the news the other day about the damage to the Arecibo in Puerto Rico. And Nero asks, do you know whether they're going to be repairing it, or whether what's going to happen to the telescope after the damage?
Yeah. So Nero asked about the Arecibo telescope, what they're going to do about the damage. Unfortunately, I talked about this on my Instagram stories and my YouTube stories the other day. Unfortunately, the National Science Foundation in the US announced about a week ago that they were going to decommission the Arecibo telescope. For those who haven't heard, Arecibo is a 300-meter wide radio telescope in Puerto Rico. You did hear me right, 300 meters wide. It's this huge dish, so all these interconnected segments. It's just the most fantastic thing I've ever seen. And the light comes in onto the dish and gets reflected back up and focused at the focus point, essentially up on where the detector is, and it's sort of like suspended over this huge dish in the middle of the jungle in Puerto Rico. For those who've seen, is it GoldenEye that it's in James Bond? I think it's GoldenEye. Yeah, it's in one of the James Bond films as well. And it's, you know, been involved in so many discoveries and detections and all sorts in terms of astronomy. It's been running since the 1960s. GoldenEye. Thank you, Sam. Quick Googling skills. What was I just going to say? So it survived like Hurricane Maria and everything in like 2017. But they think that actually might have caused some stress, because earlier in the year, one of the cables that suspended the detector in that focus point at the top of the telescope broke. And then it ended up sort of absolutely just completely ruining a huge part of the telescope dish and a load of the segments that make up the telescope dish as well. And they were hoping to fix that, but then 2 weeks ago, there was another cable failure. There was further damage, so obviously then that makes that unsafe to actually get engineers out to site, and so that's why the NSF have declared that they are going to decommission it. And I needed a day to process that information, because, you know, I use data from that telescope, and it was like survey archival data in my thesis. In terms of radio, one of the things that I use it for is that it can observe what's called the 21 centimeter hydrogen line, which is the line that you observe in radio frequencies that shows you where hydrogen gas is in galaxies, essentially. So if you want to know how much mass in gas, rather than say mass in stars, or gas is available that could be turned into stars in a galaxy, then you need observations like that with a radio telescope. And I used a survey that was done with Arecibo, and it was called the Alfalfa survey. And I'm still not yet over it. I'm really not over it. But good question anyway. I've not had a drink in a while. Might have a drink while you tell me the next one.
So we've actually got someone from Puerto Rico.
Oh, hi. What was the name? Sorry, I said oh hi over the name.
Hernan.
Hi, Hernan.
So talking about supernova. So the question is, how close does a supernova have to be dangerous to us here on Earth? So I guess, what would the effect of a supernova be, depending on how close it was?
I mean, it would depend. So I don't know if people have heard of gamma ray bursts, but we think gamma ray bursts come from a certain type of supernova. If something like that came from a supernova and it was directed at us, like line of fire, we think these might come out in sort of like more like a jet type situation. Gamma rays would obviously be devastating here on Earth. You know, I mean, I'm not talking about how we'd all become the Incredible Hulk or anything. You know, I'm talking gamma rays is incredibly dangerous cosmic radiation that could cause serious issues to our health. So in that respect, if we had a strong enough supernova that could go like give us a gamma ray burst, it would be very dangerous. However, I don't think there's any star big enough in our local vicinity that could be that kind of level of danger to us. So I wouldn't like to put a number on it, to be honest. I don't. Trying to work out sort of like intensity drop off in your head after a run or two is a little bit difficult. But I'm sure people have done that kind of calculation before. But that's what's kind of good about the fact that our sun is on the edge of the Milky Way. So I did a video about this once, that there's sort of a galactic habitable zone, like a zone in the actual galaxy itself where, you know, you're not sort of in the very center where there's a huge amount of stars, and it's incredibly, incredibly dense there, where you are more likely to be near something like that in terms of a supernova, and that would affect the development of life on a planet. So yeah, it's kind of good that we're in the sort of the galactic suburbs in terms of our, you know, survival in terms of life's evolution here on Earth as well. Not just our survival, but, you know, the fact that we've had 4 million years worth of time to evolve to this state as at the same time, right? It's because, you know, nothing like that was too catastrophic nearby. So, next question, please.
Okay. From something slightly morbid, maybe, to if you could, which one of the great scientists of the past would you like to meet in person to discuss science, and why? And maybe if you can't meet just one, maybe a dinner party with 3 guests.
A dinner party. Oh, who would I invite to my dinner party? I feel like I should have an answer for this, because this is like a question that I feel like people ask a lot, and I'm like, why don't I have an answer for this? It's like that I could just off the cuff.
Do you want some time to think?
No, I think I know at least Vera Rubin, definitely have Vera Rubin round. But I think I'd want a mix of like across the centuries, you know, so that almost like you could hear people's perspectives from the different times almost. So like I'd love to like speak to like Ernest Rutherford back when like they didn't know the structure of an atom or something like that. And then someone from around sort of the quantum, like, I don't know, like surge there was in like the 20s kind of thing when they were having all those conferences and stuff. I guess Einstein would be the obvious, but you could also have like Bohr and like, you know, I don't know, all of those people who went to the Solvay conference. Like, I've said it before, I just want a dinner party with all of the Solvay conference people. So that would be cool. But yeah, Vera Rubin was the first person that came to mind. I think just because I do galaxies, and she just seems like such a cool lady. Everybody I've spoken to who's met her just said she was incredible. So
nice. Okay. Next question from Francisco.
Hi, Francisco.
And this is scarily close to your research. Ooh. So Francisco asks, if a galaxy gets too hot, it stops forming stars.
It does. Galaxy gets too hot, it stops forming stars.
What happens after enough time if it then cools down? Can it restart star formation?
Yeah, really good question, and very close to my research. Sounds right. I made him read my thesis to proofread it, so this is why he knows. So yeah, if a galaxy gets too hot, if it's heated either by the output from accretion onto a supermassive black hole or from interaction with a cluster of galaxies or something, star formation will stop, because a galaxy needs cold gas to form stars, because it needs to be able to condense under gravity. And if it's too hot, the molecules are essentially too excited and just won't condense and get dense enough to start nuclear fusion. And so that's when a galaxy turns from blue to red, because you've got rid of all the young, hot blue stars and you're left with sort of all the old, smaller, sort of dying embers of a fire kind of red stars. There's been questions for a long time about whether galaxies can go in the opposite direction, if they can turn from red to blue, if perhaps there is some injection of cold gas, or if you wait around long enough, which we don't think is really a thing. I think it will stay hot. It will stay what we call dynamically hot for a long time. But if you have some injection of cold gas, you could maybe reintroduce star formation. So perhaps if it has a merger with like a little galaxy, or perhaps, there's some influx of gas from the surrounding medium somehow in the environment, there are various different ways. And so I know that there was some simulations done by someone up in Durham, which is where I did my undergrad as well. So I was sort of listening closely to what they were doing. It's called the Eagle simulation. It was a big sort of like, let's simulate the entire universe and compare it to our observed universe and see if we can make any conclusions. And one of the things they looked at was how many galaxies were going the opposite direction from red to blue. And they estimated it was about 17% of the galaxies that were sort of in the halfway house between going from blue to red, what we call the green area. About 17% of those were going in the opposite direction. So that's not something we could necessarily glean from observations. So it's a pretty cool number that the fact that pretty cool that they can even put a number on it, but the fact that it's that high, I know 17% doesn't sound high, but it was high, and I was quite shocked by it when I read it. I was like, oh wow, that many, that's cool. So there you go. Good question.
All right. Next question from Mike.
Hi, Mike.
Related to a recent video of yours, actually.
Mm-hmm.
At what age did you learn coding?
Mm-hmm.
Do you wish that you learned it earlier? And do you think kind of children now should be exposed to it earlier in school, I guess?
Yeah. So I didn't learn to code until I got to university. A Python course was part of our physics course up in Durham. And yes, I massively wish I'd learned earlier than that, because I didn't get it straight away. Like I didn't get on with it at all, coding. I just didn't understand, the terminology, the idea of it, the like, why would I need to do it this way? It just seemed very contrived. Me and Sam were both at uni together, and I remember just being like, how did you do it? And copying you, and it used to drive you insane, didn't it? But eventually something clicked and I just got it. And then I absolutely loved it. I thought it was the best thing ever. I was like, this makes my life so much easier. And I did my whole master's research project with Python as well. And I now use Python every single day. And I wish that, I had maybe learned it myself or was introduced to it at school. Like I took like the equivalent of computer studies, like IT at school. And I did it for like a GCSE, which is sort of our exams we take at 16 in the UK. And I never once learned to code. I learned how to conditional format an Excel cell so that it turned red when something went into negative numbers. And I'm like, I've never used that once in my life since I left school. I would have loved to have learned to code instead there. So I really do think that kids should be introduced to it from a young age, just because so much of life is now, done by code. So okay, you've got the entire internet and whatever, but think about algorithms that decide what we watch, what we listen to, what we read next on sort of Spotify, Netflix, Amazon, all that kind of stuff. Like, oh, because you bought this, would you like this? Or these adverts were shown on social media. That's all done through coding and algorithms. And I think people need to understand how that works so that they can understand the benefits and the shortcomings of it as well. And so I definitely think that should be taught in schools. So, not just because it's good for astrophysics. So it's just so important.
All right. So we've had a few questions on this topic. So what future space missions are you looking forward to? But also future telescope projects. Anything you're particularly interested in?
Yeah, so future space missions and future telescope projects I'm looking forward to. So obvious one, James Webb Space Telescope. We've been saying it's going to launch next year for about 5 years now, but it should be 2021 as long as there's no more delays because of the pandemic. They've been working through the pandemic, and it just hats off to them over at Space Telescope Institute in Baltimore. They've just done such an incredible job. Obviously looking forward to that. I'm looking forward to the new 30-meter optical class of telescopes that are going up in Chile and in Hawaii possibly as well. We've got the Vera Rubin Observatory in South Africa too, which is supposed to observe 1 billion galaxies rather than the million that the last biggest survey did. So wow, and that's going to massively increase my sample size of galaxies. That sort of telescopes, I guess. Space projects, I'm so excited for LISA, which is the gravitational wave detector that's going to be in space. So like LIGO in the US and Virgo in Italy, but in space. And it's going to be even bigger as well. So it's actually going to be sensitive to different frequencies, which it'll mean it will detect gravitational waves from supermassive black holes rather than gravitational waves from little piddly black holes in the Milky Way, which are from supernova, something like 30 to 40 times the mass of the sun or something. I call those piddly black holes. So I'm very excited for that because it'll sort of inform our ideas of what happens when two galaxies merge. Do the two supermassive black holes at the center merge? How long does that take? All that kind of stuff. And we are officially halfway through. Whew. So yeah, good question. Ooh.
All right. There've been a few questions on this as well. It's not something I've heard of, but apparently there's been a result published that actually the solar system and Earth are closer to the center of the Milky Way than previously thought.
When was that published? I haven't seen that.
I'm not sure. Something about a couple of thousand light years close to the center of the galaxy.
A couple of thousand light years I can totally believe, because a couple of thousand light years is nothing in terms of the scale of the galaxy, right? I could totally believe that maybe the galaxy is slightly bigger than we thought, for example, because, you know, seeing the stars on the edge of the galaxy to work out how big it is difficult, because they're obviously quite far away and they're quite faint. So yeah, I could totally believe that, but I would definitely have to read up on that, and maybe I'll pop it in Night Sky News for December. So thanks for giving me a little tip on that one. Who's that question from?
About 3 or 4 people.
Oh, okay.
Things, yeah.
Cool. All right. Well, I haven't seen it yet, but I have had a couple of days more restful over the past couple of days. We put up Christmas lights outside today. Not got the tree yet. That's next weekend, but Christmas tree lights outside was fun. Oh, that one had a very floofy Y. If you get that one, you got a very excitable Y, because I was talking about Christmas. Little tiny Tim when it comes to Christmas, honestly. I can see the live chat going crazy. I just see it pinging through all the time. So I don't envy you having to go through it, Sam.
That's all right. I'm just scrolling.
He's scrolling. I'm very excited to watch his Dark Materials when we finish this. Has anybody been watching it with the sort of dark matter that's actually the dust in it? Like Mary Malone, who's the physicist she goes and sees, like actually, like from the description in the book, she works in the building that I work in Oxford. And I was like, BBC, I could have played Mary Malone. I could have been the dark matter scientist. I don't know that I'm a dark matter scientist, but I could have been that person who Lyra went to. Was not to be. Plus, also in that building that I work in, as you walk towards the lunch canteen, you do pass a room that has Dark Matter Lab written on it, so it's definitely that door as well. But in the TV program, she goes to St. Peter's College, because obviously the colleges look a little bit nicer and older than the sort of concrete block that I work in.
All right. Here we go. A bit of a light one from Alan.
Hi, Alan.
Recent video reacting to Star Trek.
Yeah.
Have you watched any more episodes? Have you been hooked?
No. That was so funny. I don't understand how I managed to offend so many Star Trekkies. I said, like, I've never watched it. I'm sorry. But so many people were like, I don't buy it. I don't buy it that she became an astrophysicist and she never saw Star Trek. I was like, first of all, I was born after Star Trek, like TNG even started. Like, second of all, by the time I was interested in sci-fi, I don't think Star Trek was probably on my telly anymore. So yeah, I managed to somehow do it. And also, like, those kind of videos, they're so much fun to film. But the idea is literally to get as much astrophysics in it as possible. So you try not to sort of sci-fi bash, because you're like, yeah, it's part of the plot. Like, they need this for, you know, the plot to move along. Just kind of pointing out, like, this is what it would be like otherwise. But by doing that, I poked a wasp's nest. Let's put it that way. It's been so much fun reading all your comments on that. I definitely want to do more videos like that, because I just think it's a really fun way of like getting over a load of astrophysics content about like supernova, like that one was about, and collapse of stars and everything like that. It's just a really like fun medium, I guess, to get over that kind of information. So yeah, I really enjoy it. I thought it was really fun. So yeah, I've been recommended lots of things like The Expanse on Netflix, which I've heard really good things about. People were asking me to react to Firefly the other day, and I was like, well, it wouldn't be a reaction because I have seen Firefly. Although it has been 5 years since we watched Firefly. So maybe I could react to Firefly, but I still don't think I'm over the end of Serenity yet. So still not over it. Stop talking about sci-fi and answer some astrophysics questions now.
Okay, I've got a question from Yuvan.
Yuvan, hello.
Who's an aspiring astrophysicist.
Oh.
And would like to know, are there any books you would recommend for an aspiring astrophysicist to read and kind of get into the subject area?
Yeah, I mean, it's a little bit difficult because, I mean, you've got obviously public science books, with like the thing that I've written as well for the public, that are written, you know, for people who are really interested in it, but it's not necessarily going to go into the same level as detail and derivation as like a textbook. So it depends what you want. If you want a textbook, I would look up, say, you know, whatever universities you're interested in going to, you know, what textbook they recommend for their course kind of thing. And then have a look in into it in that way. But if you're looking for like more public science books, obviously there's my books that you could purchase. But I really enjoyed recently, Katie Mack's got a book out. It's called The End of Everything, Astrophysically Speaking. So if you're into the sort of like cosmology side of things, like how did the universe start? How might the universe end? Her book is fantastic. She's such a good communicator. I really, really loved it. Lisa Harvey Smith, who is a Brit who's sort of now decamped to Australia. She has a book out as well, which is called When Galaxies Collide, which takes a look at everything that would happen when the Milky Way and Andromeda collide in the future, which is, again, a great book. Jamal Khalili's just got a new book out, so I haven't read that yet. But if anyone's read it, let me know. I really want to read it. So yeah, those are the ones that I've read recently. I'm trying to think what else I read. Oh, I've got a couple in here. I know The Big Splat I've mentioned before on my channel. That was a great, great book. I got this when I was about 17, called Dark Side of the Universe by Ian Nicholson. This was fantastic. It was all about sort of like dark matter, dark energy, and all the research that's been done. It's actually, this is about halfway between a public science book and a textbook. So I would actually massively recommend this because it actually sort of like states the research that's been done, you know, sort of like how we know stuff, not just what we know as well. So I really, really, really enjoyed that. So you should totally get that one. And then this one, which looks at the history of how the moon formed. That's a fantastic book. It's very much about the history rather than the science necessarily. But yeah, oh, I can't get that back in now. Oh, it's just going to get on the top. Sorry. But yeah, that's the book cupboard. It's good that I almost sat here, so I was by the book cupboard. The pen dried out in the moment that I got the book cupboard open. There we go. Oh no, I just picked up the wrong pen. I'm back to the old pen. No,
right.
no.
Next question from Pablo in Chile.
Hi, Pablo.
Pablo asks, what's it like to work in both kind of research in science, but also outreach and communication from a kind of time and dedication to each aspect?
Yeah, it's a bit difficult. It is a balancing act between research and doing science communication and YouTube. It was a lot easier when I was going into the office every day because I edited and prepped all my videos whilst I was commuting because I had an hour commute on the train. So that was fine. Now I'm at home. I'm sort of like managing my time in sort of those hour blocks isn't really as feasible. So I've had to sort of switch around how I do that. But I, you know, spend about 90% of my work week researching, right? And then the rest of the 10% and then a little bit of my sort of downtime is, you know, YouTube and all of the other social media stuff I do, like the RAS podcast I do as well, the Supermassive podcast, which is great. Because obviously outreach is such an important part of being an academic as well. We are funded by the taxpayer, and so you want to give back to the taxpayer. So my department, the Department of Physics, you know, they expect everyone to do outreach and they expect to spend some of their time on it. So it's an important part. And it's an important part of all my job applications as well. You know, the fact that you do outreach, it's so expected of you. So it is part of like my, you know, fellowship that I'm paid to do. My research fellowship is also to do some outreach. And so I decided to do YouTube, which I really think I've carved myself out a niche there. But it does get a little bit difficult, especially because with science, like, you have this overarching big question you want to answer, you know, some big hypothesis you're testing. And that kind of a project can probably take like a year, if not longer, from getting data to analyzing data to figuring out what the data is trying to then tell you after you've done the analysis, to figuring out what that means in the big picture, writing that up all in a paper and getting that published. You know, it's a long kind of time scale in terms of like, you know, feeling like you've ever ticked anything off your to-do list. It's a very sort of long time you have to wait for any sort of reward. And so I actually really quite like the fact that YouTube once a week, although it's a big commitment, like it does give me a bit of a creative outlet, you know, and it's kind of nice to feel like I actually got that thing done in a week, you know, which is not usually something that I do in terms of research. I'm only ever ticking things off the to-do list once every month or two. So yeah, it's yeah, the time management is a weird one. Because it can always feel like YouTube is the most urgent thing because of the sort of shorter deadline time, but you have to sort of just balance it out as best you can.
All right. Question from Jockney.
Hi, Jockney.
Hi, Becky. How difficult is it to get time on a telescope like Hubble? And how do you decide what to use that time on, given that it's so precious?
It's very difficult to get telescope time. So most telescopes are massively oversubscribed. I put in a Hubble Space Telescope proposal this year, and I put in a Muse telescope proposal this year, and both of them didn't come through. And that's not to say that like a proposal isn't good when you put it in. It's literally just that they're so oversubscribed. You know, something like Muse and Hubble's probably like the amount of hours that people ask for, because you have to, so you said like, how do you decide what to do? You actually have to, in your proposal, say, this is what I will observe and these specific galaxies, and this is how long I need to observe each of them for, because that's part of the decision-making process on the panel is how much time do we have to give? And so in terms of the number of hours asked for by astronomers versus how many hours they have to give, it's 20 times oversubscribed. And something like Muse is about 10 times oversubscribed as well. So, it just means in terms of like probabilistically, you're probably not going to get it. So it's very difficult. But then obviously when your application isn't successful, you get feedback as to why not. Oh, the panel had some doubts about the feasibility of this, or perhaps it's literally just, it was great. It's just that there were others that were particularly great that we wanted to give the time to more. And so you just put it in again on the next round 6 months later, and you try again. In terms of how you decide what to put in for in a proposal, it's literally, you know, you've done some research on something else usually, and it's raised another question. You think, oh, well, how am I going to answer that? And you think, well, what I'd need to answer that is this kind of data. What telescope can give me this kind of data? Oh, this one can. And then that's how you sort of end up in that area where you're putting together a proposal saying this is what I'll observe and this is specifically how I'll do it with this instrument. And it's a very laborious process as well, because every telescope is different, and if you've never used that telescope before, it takes a good couple of weeks to get your head around, you know, everything you need to do in terms of calculating how long each galaxy needs to be exposed for, given how bright it is, etc., etc. So it's quite a difficult process. It's not one I do enjoy the sort of putting together proposal, but writing the proposal, I'm just a bit like, well, just give me the time. It's a really good idea. Can't get on with it. Well, that one was quite a flourish. Woo! Coaster stuck to the bottom of the glass. So, RIP headphone users.
Okay, next question is from Andy.
Hi, Andy.
Andy wants to know, if you weren't working in academic research, which other space-related industry would you most likely be working in or want to work in?
Yeah, so I actually, when I graduated from university, I wanted to work in satellite technology, because it seemed kind of like if I didn't want to do research, you know, what was the industry I wanted to work in. I really liked the idea of sort of being responsible for, you know, getting something into space. But I quickly realized that sort of the engineering side of that I wasn't a big fan on. And then I wasn't a big fan of the management side of that either. Like, I didn't just want to be, you know, like writing a project plan or something like that and just sort of like constantly haranguing people to get stuff done and making sure that everything was on schedule. Like, I didn't want to be a project manager. And I quickly realized when I was in the industry that I really just missed astronomy and I just wanted to talk about space all day. And so that's why I came back to research. I think if I wasn't in astronomy research, I'd be in marine biology research, because the sea is my other great love in life along with space. And I'd be doing some sort of coral reef or dolphin conservation or something like that. I once at one point wanted to be a surgeon when I was about 16, 17 as well. I think that would have been quite cool. So yeah, lots of different things that I thought about. I guess the dream job is the person who names nail polish colors, because that's the most punny job ever. And I'd love to do some sort of like space nail polish line one day and give them all amazing space pun names. But yeah, good question. I have a fun thing about marine biology and astronomy crossover, actually. The algorithm that if you can sort of feed it a picture of the night sky, it can sort of triangulate where you are and be like, oh, okay, this is a picture near the Orion constellation. That same algorithm is used by marine biologists to work out what whale shark they're looking at. So the whale sharks, those big blue ones with all the white dots on them, and it's the exact same algorithm that triangulates, because the dots are specific to each whale shark. And that algorithm was developed by astronomers. So it's a pretty cool little piece of knowledge, and I love it. I just love the fact there's a marine biology astronomy crossover, along with the whole, you know, like coral reefs like release their polyps during a full moon, I guess, and it's a very specific full moon, and it's like, how do they know? I love those kind of crossovers. Crossovers between sciences are awesome. I'm starting to think that my own name looks like it's spelt wrong every time I write it. Probably about 300 in, about 100 to go. We got loads of questions coming in.
Yeah. So the next one is from Roy.
Roy, hi Roy.
And he's saying, what was the reason that the US and North American version of the book has got a different title and different
cover? Just the pub. I don't understand the publishing system. That's all I'll say. You could ask the same question for Harry Potter, right? Harry Potter over here is called Harry Potter and the Philosopher's Stone. Why did they change it to Sorcerer's Stone in the US? Because they thought it would work better with the US market. And that's what the marketing people at my publishing company told me. And I said I would really prefer it to have the same name because my YouTube channel is worldwide. But they said, no, we really think this will perform better. And so, they bought the rights independently to the UK rights for the book, which is sold in the rest of the world. And so they wanted to sort of put their own stamp on it, which is why it's got a different name and a different cover as well. And that's the one that's available in the US and Canada. So I don't really question it. I mean, they're the people with, a huge amount of experience publishing in the US. So I figured they knew best. And I went with what they knew best. But yes, it is very frustrating when people are like, oh, we've got a new book out. And I'm like, nope, it's the same book. It's the same book.
Okay, next question. How much travel is involved in your job? So astronomy research, how much travel do you do?
Who was that from, or is there lots of people asking the travel question?
A couple of people have asked that one.
Oh, okay, cool. So Sam asked how much travel is involved in my job. In non-pandemic times, a lot of travel. Yeah, I have a lot of colleagues that travel way more than me as well, and I already travel quite a lot. So obviously you have to travel to telescopes, so that is usually in very far-flung places like Chile and Hawaii and New Mexico and La Palma and South Africa and Australia, India as well. So there's they're all high up and very remote. So you have to travel for that. But then also a lot of conferences as well in my line of work, presenting your research, networking with people. The conferences are some of the favorite parts of my jobs. And what I love about astronomy conferences is everyone seems to organize them in really nice locations, like islands somewhere in the world. So I've been to conferences all over the place. I had a great one that I went to in Sydney, which was right on Circular Quay as well, in the Police and Justice Museum. It was such a fab location for a conference. I got the ferry every day and it was great. Just like into Circular Quay, past the Opera House and the Harbour Bridge. It was so cool. Cozumel, I went to a conference and that was fantastic because it was an all-inclusive resort that was paid for by the university. It included food and alcohol. There was a swim-up bar. There was a lot of networking done at the swim-up bar. There was, like Dartmouth as well, which is a fantastic place to visit in terms of I'd never seen like a US campus university before. Toronto, Catalina as well, off the coast of the US, which was fantastic. South Africa as well, went to Cape Town for a conference. So yeah, lots and lots of travel. And I love it because I just think it's amazing that you can see all those kind of places as part of your work. I always do a couple of days either side of the conference starting, so I can see, the place that I'm visiting for a couple of days too, which is great. Not been traveling in a while though. Had so many trips cancelled this year, which was not great. Hopefully going to La Palma for observing in January, and I'm hopefully going to do a vlog of that as well, very early January, to use one of the telescopes there. So that'll be really fun, but hopefully that will go ahead. We shall see.
Again, a few people have asked this one.
Mm-hmm.
Bit of a fun one. Have you ever chatted about dust with Brian May?
I've been chatting about dust with Brian May. Oh, I would love to have a chat about dust with Brian May. So there are people in my department who know Brian May because obviously he's such a keen astronomer. He once did. So for those who don't know, Brian May is the guitarist from the band Queen. And he did a PhD in astrophysics before he joined Queen. Literally as Queen were forming, he was doing his PhD in astrophysics. And they signed the record deal like 2 years into his PhD, and he never finished it. And I think he went back in the 2000s to finish it. And it was all about dust in the solar system, which is sort of like someone has to study dust. But there are now people in my department that know him because he is such a keen supporter of the work that goes on. So my PhD supervisor was Chris Lintott. Those in the UK will know him as the host of The Sky at Night, which I am going to be on in 2 weeks' time. It's very exciting. And they interviewed me for that. And he's always said, oh, yeah, one day you'll meet Brian May. And I'm like, it's been 8 years, Chris. When am I going to meet Brian May? So, yeah, I'm sure it'll happen one day. But one day is not today. And I am sad. And I will surely bring up dust. That the thesis that I actually had in the video that I recorded, everyone noticed that he had signed the front of it, and that was actually Chris's copy of his thesis. Sorry again.
All right. Question from Mitch.
Hi, Mitch.
Asking about the difference between Earth-based telescopes and space-based telescopes, and the effect of the Earth's atmosphere for ground-based telescopes. Could you talk about the kind of pros and cons of the two?
Yeah.
Two types?
Okay. So basically, you would always want a telescope in space because the Earth's atmosphere is just really annoying in the fact that it does disturb the light. Obviously, the pro of having one on the ground is that it's a lot cheaper. If anything breaks, you can fix it. The Earth's atmosphere essentially distorts your light. So, if you've ever been in a plane and you felt turbulence, that's just pockets of air that's disrupting the movement of the air through the engine. Those pockets of air are different temperatures, and they disrupt the light on its way down to the telescope as well. The Earth's atmosphere also scatters light as well, which means even at nighttime, you've got scattered light running through the atmosphere, which is going to be a noise in your image. You've then got humid air as well, which massively distorts the light on its way down to the telescope too. There's very clever things that you can do where you can point a laser into the sky and you can record how the laser has been affected and therefore remove those effects from the light coming back down, kind of like noise cancelling headphones for a telescope, right? They hear the sound that's coming in and they invert that sound so they can remove it. It's kind of the same thing. You invert the distortion to the light to remove that distortion from your final image. It's called adaptive optics. So you can mitigate for it, but it's just not the same as taking an observation in space. But as I said, it's just really expensive. And obviously some observatories you have to do from space. So for example, X-ray astronomy, the Earth's atmosphere blocks X-rays. Great for us down on Earth, but not great if you're an X-ray astronomer because you can only do your observations from space.
Okay, again, quite a few questions on this topic. So the question from Dana is the most recent one.
Hi, Diana.
Would you go on a space mission to Mars, knowing that currently you'd not be able to come back to Earth?
No, I wouldn't go. I wouldn't go knowing that you couldn't come back. Definitely. Just because like family and friends, like I don't fancy just a one-way mission with 8 other people or something. That just doesn't sound like fun. Like the best thing about going on a trip is coming home, right? And seeing family and friends again. That's what gets you through. Like going on a trip and not being able to come back, I don't think I could ever do. I totally get it. Like go up to the ISS. That would be great. I'd love to go up to the ISS. That's just like a long flight. And see the curvature of the Earth and just the Earth from space and have your perspective changed in that way, I think would be incredible. I'd go to the moon because I've known I could come back, sure. But Mars, one-way trip, I don't think I'd even go like knowing you couldn't come back. It just seems a little bit too far away and like that you just increase the probability of something going wrong. So maybe I'll just never realize my dream of becoming Mark Watney. Took me a while to remember his name. I was like, not Matt Damon. That's not his character name. I've already got Patrick Stewart's character name once this week. I can't get another character name wrong. Another question master? We're almost there. I think we got about maybe 50 or 30 left.
I'm just waiting for some fresh ones to come in.
Oh, the chat's going crazy for me. Maybe it's delayed on my end. I hope all the US people watching had a very nice Thanksgiving the past couple of days. We were going to make a pumpkin pie on your honor, but I'm going to wait till next weekend when we put our Christmas tree up, so it's all like festive and cozy. So, oh, I can see one that says, "Have you visited NRAO at Greenbank?" I haven't. I would love to, but I haven't. So, there's lots of telescopes I haven't visited that I would love to. I still haven't been to Chile. I haven't been to the Atacama Desert, and that really is just like astronomy central. If you're an astronomer, everyone always says the Atacama Desert is just the best place that you can be. And the funny thing is as well about observatories is that, so for example, when I went to La Palma, to the Canary Islands, it was fantastic. I was about maybe 2,000 meters up. The sky was absolutely incredible. I could see just the most amount of stars that I've ever seen. Then when I went to Hawaii, which is over 4,000 meters up, I could barely see anything. And that's because the oxygen, the air is so thin up there that there's just not as much oxygen. So your brain redirects it to your internal organs, which are obviously much more vital, and not to your eyes. And so you can't see as many stars. And they actually have this little oxygen tank that's there in case anyone does get altitude sickness. But apparently people do this where they just like take a hit of oxygen and all of a sudden just all these stars appear in the night sky, which would just be incredible. I don't know like what that'd be like in Chile. I think it would be similar because I think it's 4,000 meters up there too, if not just less than it. So I would still love to visit though, because again, another place that they have filmed a James Bond at was at the Residencia in the Atacama Desert. Oh, it's the last one. We hit the last one already. I can't believe it. Last one, everybody. I'm going to draw a little galaxy on the last one. So whoever gets the last one will know that it was the very last one. There we go. It's a little barred galaxy, look. There you go. You'll know if you got the last one now. If it's got that on it. All right. So that was 400 signatures on these stickers. I'm now going to send these back to the US. They're going to get stuck in books. If you want to purchase one of these books that has been sort of not virtually signed, but long distance signed, then I will put the link in the video description of this live stream just when I finish the stream. And I'll also share it on my social media and a YouTube community post and all that as well. But yeah, is there one last question while I sort these out, because they're absolutely horrendous and they're not all lined up? Can you find me one, or should we just wrap it there?
People are asking where can they get your book from, these signed versions?
Yeah, I'm going to post the link in the video description so that you can get a signed version. If you want to buy the book normally, if you're not in the US and Canada, then any of the major bookstores should have it. If they don't, ring them up, do a query, ask them for this book, and they should be able to order it in for you.
Okay, got one last one.
One last one.
Do you remember the first time you saw the Milky Way galaxy in the sky with your own eyes?
Yes. I was about 12 or 13 the first time I saw the Milky Way with my own eyes. And for all the Brits watching, it was at Centre Parks, which is essentially like one of these like holiday resort kind of things that's in the middle of a forest somewhere in the middle of nowhere. And you've got these little wood cabins that you stay in. And you can do like horse riding and mountain biking and paintballing and all that kind of stuff, outdoorsy activities. And I remember one night we were like cycling back from the leisure centre, where we'd all been swimming and like we'd been on the water slides and stuff inside. And I remember looking up as we got to our house and it was just pitch black and the Milky Way was just above my head, and I was just absolutely in awe. And I was already pretty into space by that point. Like from about 8 or 9 onwards, I was like, space. I want a telescope, I want a load of books, but I still hadn't seen it from where we lived properly. And I just remember being absolutely amazed by it. And if you haven't seen the Milky Way, then make it your priority. Like next time you go traveling or you go on holiday somewhere, try and get away from lights. Beaches are a great place to do this and stuff. And try and, get just somewhere where you can spend 10, 15 minutes just even lying there and letting your eyes adjust and to see the Milky Way in all its glory, because it really is incredible. And if any of you are from the Southern Hemisphere, you guys have the best view. So you've really got to do this because you look towards the center. So yeah, good last question to end on. Nice and reflective. Thank you so much, everybody, for spending your Sunday afternoon, evenings, night times with me. I really, really appreciate it. This is my third live stream this year. The first one was hitting 100,000 subscribers in February, and we're now, getting towards 200,000 at the end of the year as well. So yeah, it makes me feel all warm and fuzzy inside. I'm so grateful for each and every one of you, for your time, all of your questions and everything. And I hope you guys have a really nice rest of your Sunday. Enjoy. Bye.